All right, today we're going to talk a little bit about one of the reasons why I love D3. This is going to be a series of videos that kind of deal with the fundamental concepts that have made D3 the visualization powerhouse that it is. We're going to start with two different foundational concepts. We're going to skip the first one and only talk about the second one. So when you have a data set, your data set is usually made up of rows and columns. And an easy way to think about D3 is D3 relates directly to those rows and to those columns. So the first foundational concept is every single row gets a mark on the page. So if you have 20 different rows of data in your data set, you're probably going to have 20 different columns in your bar chart. If you have 1,000 different rows in your data set, you're probably going to have 1,000 points on your scatter plot. We're going to skip that one, come back to it in a future video. The second one is the one that I think is more interesting. Every single column can be represented as a visual aspect of those marks on the page. So for example, if you have height or age or count or any of those as a column, those can be reflected in, let's say, the length of one of those bars. So the bigger, the older someone is, the longer that bar can be. And you're like, that seems pretty boring. And I promise that it seems like a very simple concept, but these two concepts being built into D3 makes it the most flexible thing that you'll ever deal with in the history of the world. These concepts don't just come from D3. I think a really good source is a book called Semiology of Graphics, made by a French guy named Jacques Bertin. It's published in 1964, I think, and it's the craziest book. I don't own that many DataViz books because I don't love most of them, but this book is amazing because there are crazy graphics in it. Oh, can I not see any of them in here? Terrible. Yeah, so a lot of charts, you see this one thing of France right here, and he has ones that just get crazier and crazier and crazier. And eventually you're just like, this man is insane. But in terms of breaking things down as to what you can do with these two rules, every single row, every single point in your data set gets a visualization, and every column can be a visual aspect of those marks. You can go to crazy heights. So I'm going to show you a demo of an example of this. I've made a JavaScript page. It's powered by D3, but we're not going to talk about the tech behind it in this video. We'll talk about it in a future video. So I have a few different cities, and each one of these cities has a population. And I've represented that population by the number of millions of people in it. So we are going to make a visualization of these 5 cities. So if I have these 5 cities and I am following these rules and I want to use circles as my visualization, I should probably take 5 circles and say every single one of my data points gets a circle. But now the second rule. The second rule is every single column can be represented as a visual aspect of those marks on the page. So what do we have? We have population. So how can we change these circles to reflect the population? And the first thing you're going to say is the size of the circle, make a larger circle for a larger city. And I say, great, but we're not going to do that yet. We're going to start with color. So as you see here, Washington, D.C. is the smallest, so it's the lightest, and Delhi is the most pink because it is the largest. Now, was it an accident that we chose white as the smallest and a much more saturated color as the biggest? No, because if you look at this, you kind of visually think, break it down as, oh, there's more color here, so there are more people. But how many more people are in, let's say, Delhi than Jakarta or Los Angeles versus Washington, D.C.? You can't really tell. It's kind of a hard judgment to make there. Is it twice as many? Is it 4 times as many? 100 times as many? With color, it's not really the best for dealing with exact quantities. In a future video, we'll kind of go down the list of what different kinds of visual aspects of a data point is best at conveying different kinds of information. Now we can go to circles that are sized differently based on the number of people in each one of these cities. So this is probably what you thought of first. As we increase the size of a city, or as the size of a city increases, as the population column gets bigger, we connect that with the radius, the diameter, the area of this circle, the size of the circle. There's a lot that kind of goes on about how to understand what size of a circle actually means. And again, we'll get into that deeper in a future video. Now, because all of these circles are different sizes, we actually don't need to space them out on the x-axis anymore, right? We can just stack them all up on top of each other, and it's much easier to kind of compare which ones are bigger than others and kind of how much space is in between each of them. That's fun, right? So even though these both compare by size, they're completely different visualizations because we took away the power of the x-axis there. We said, nope, we're not moving you, spreading you out along the x-axis, we're just putting you all in the same spot. Now, what if we only cared about the x-axis and we said size doesn't matter anymore. We're only going to care about the x-axis. There you go. Smallest on the left, largest on the right. The far, far, far left, you see that little side of Washington, D.C. that has that line. 0 is going to be over here because Washington, D.C. has 0.7 million. And then we move over to Delhi, which has, I think, about 20 million. So now, instead of using size, instead of using color in order to represent this column here of population, instead we're using X position from the left to the right. But what if, your boss says, hey, color is fun. I really want some color. You throw some color in there too, and you say, great, I colored it. Is this the same as the color that we used before? No. These colors here, yes, they all have different colors, but it's not representing population anymore, right? Because you don't go from green to orange to purple to green to pink, right? It's just kind of, these are random colors that just mean categories that just mean these are different cities. They don't belong into, these two aren't grouped together. These other ones aren't grouped together. They're all individual. We could say that they represent this column right here, the name column, because every single one of these cities has a different name, and therefore every single one of these cities has a different color. But most of the time, when you're going to be dealing with these visual variables, things like size, things like width, height, color, all of that, you're mostly going to be dealing with numbers. So even though that didn't seem terribly fascinating, I'm sure, that we could take this same number, this same population, and use color to describe population. We could use size to describe population. We could stack them, display them two different ways using size as a visual variable for population, or we could use X position for it. So it might not seem like the most exciting thing, but I promise once we get into the next video about how to put this into use with D3 and head on from there, it will be one of the most important things that you ever deal with when you start building visualizations.